Namaskar. Good afternoon, sir.
Namaskar.
Namaskar. How are you?
Fine. How are you? Oh, so nice to see you all there. I wish I were there. Huh?
Yes. We also wish that you should be here. But okay, at least we can see you in the computer. So that is also something great.
But
Great technology.
we have to wait. Namaskar. We have to wait for 10 minutes or
What about others? All are here? Yeah. डोर बंद कर दूं? डोर बंद कर दूं? नहीं तो आना जाना करते रहेगा. Okay, I think we can start. There is no need because they had gone for lunch in our guest house. You know, our international guest house. So from department, it took little bit time. So that is why I told you.
No, we can wait. We can wait for another 10 minutes. It's okay for you, me. No problem.
No, there is no need. Actually, there is no need. Then we can interact in a month later. We will get some more time to. They will get not to eat. They will get more time to learn from you. So there is no need to wait. 10 minutes time, they can learn. ऐसे लोगों को बोल दो. ऐसे लोगों को बोल दो हम स्टार्ट करने जा रहे हो. Just मैं ज्वाइन तो करके इधर उधर जाता है. ऑनलाइन में है. Online, they are present there. Tell them to switch on their camera. ना ऑनलाइन में जुड़ने क्या ऑनलाइन में जुड़ के लोग कहाँ जाते हैं तुम भी जानते हो मैं जानता हूँ इसलिए पार्टिसिपेंट भी कितना 22 आया है नहीं तो 100 पार्टिसिपेंट आ जाता ऑनलाइन होता 1000 भी आ जाता.
Okay.
Okay, because everything is because we have different collaborators, so I want to know our collaborators are present there or not because we have given them time 2 p.m. time, so they are present. Another group of people are present there, so I was interested to confirm that. Okay, good afternoon, everyone. It is our privilege to have stalwart of aquaculture, Professor S.K. Kaushik, as a speaker in this faculty development program of University of Delhi. Professor Kaushik was the director of research in INRA, National Institute for Agriculture, France. He was also European Research Area Chair position, University of La Palmas in the Gran Canaria Islands, Spain. His area of research is fish nutrition. He is closely associated with various prestigious organizations like FAO, UNDP, World Bank, European Aquaculture Society, and so many. He has published more than 300 research papers, many books and book chapters with countless citations. He has been serving as a consultant in many reputed fish feed companies. His lecture will be very useful in the context of recent policy of Government of India to promote aquaculture. Sir, please.
So how do we go? I start presenting my presentation.
Whatever you like, you can tell something or you can go.
Okay. Before I start, I wanted to say, yes. I want this message. Can you see the screen? I just learned a few hours back that Dr. Kamalkan Jain from CFA passed away.
Very sad.
So I just wanted to, because all of you are teachers, at least that's what I guess, that you're all teachers, and he was one of them who has been highly appreciated by the whole fisheries community in India. All the students, they respect him and appreciate him. So this is just wanted to say that. Okay.
before that we can spend 1 minute of silence for in his memory, just 1 minute. Okay, we
That's up
can
to you, please. Yes.
stand and Kaushik.
Okay.
Okay, sir.
Is it okay now?
Yes, sir.
Okay. I'm sorry. I will go back to my slides.
Yes, sir.
Okay. Yeah, okay. Can we see the slide, please? Thank you.
Yes, sir.
Yes, sir.
Yes, thank you. Okay. I have to thank Professor Reena Chakravarti for giving me this opportunity to be part of this skill enhancement for sustainable aquaculture. And you have already, I think you have already had a lot of information over the past 3 days, including that of Dr. Jaina and other people from India, as well as Professor Sofaluz. So my talk will be more on nutrition and feeding. So thank you again for giving me this opportunity. When we talk about aquatic food, seafood is the term which is always used everywhere in the world, including that of FAO. Seafood, in fact, it comes from both freshwater and seawater. Aquatic food production. When we look at food production, this aquatic food production is the only food production sector where harvest, capture fisheries, and farming complement and compete with each other. Here we see the picture of a lady carrying, Delhi market. And so you don't know which one is from aquaculture, which one is from fisheries, capture fisheries. So that's one thing which is totally different from all other animal production systems. Land animal production, which are almost all of them are from farming with the human intervention.
Okay,
Second
so
point,
sir, is it possible to enlarge the full, make it full screen? Full screen.
Slideshow.
Full
sir.
screen. So what should I do? Yes.
Then click at the projectors bigger one.
Projector mode. My God, I don't know what's wrong. Okay. Is it okay now?
More.
एक कोई बोलो, एक बोलो. आप लोगों में से कोई एक बोलो.
Is it okay now or no? Oh, sorry. Wait a minute. I'm sorry. The whole thing is. I see you.
Yes, I'm. ये तो बोल दो भाई. अभी सब तो एडवाइस कर रहे हैं. अभी या तो कुछ बोलो कि.
No.
Help him. अपनी सूट पे आ जाओ.
Sir, no, sir, we are not able to see your slide. You have to share it again. Sir, you have to present your entire
Oh, really? Is it better now?
Like you have to sir present your this thing screen share.
Goodness, I don't know what's happening. I'm trying to present.
You already present. If something goes wrong,
You have all.
Yes.
we know how to present because we already presented. इसमें कुछ हुआ नहीं.
Sir,
My
kindly.
goodness, I'm sorry. I should have tested before. I'm a bad teacher.
You have to go to like the presentation sharing. Sir, you are in presentation mode, but you have not shared your screen.
Yes.
We are not able to see. So you can first exit out of presentation mode. Then you have to share your screen first. We are not able to see your screen, sir.
Okay. I have to now.
हमारे से कुछ हुआ है शायद.
Is it okay now?
Yes, sir.
Yes, sir.
Now your
Now it's full screen.
slideshow.
and then you have to go the slideshow. Yes, okay, now it's perfect. Okay, sir.
Perfect. You are a very good teacher.
Okay. I'm sorry.
No need to.
Okay. That's why it was useful to have some time before. Okay. Now you can see the screen and the movement of the laser, everything. Okay.
Everything.
Okay. So, having said this, when we talk about seafood production, I'm sure you have seen this picture number of times. This is aquaculture is increasing, capture fisheries stable. This is the capture fisheries past at least 30 years. It has not changed. It's about 100 million tons. Then aquaculture has been growing. And this portion is aquaculture of inland waters. And here is marine waters. But mind it, marine waters, it includes a lot of seaweed, not fish. So we have to be careful when we're talking about numbers in aquaculture, how much is really getting into the human food system. Nevertheless, over the past 30 years, global capture fisheries is stable or 10% increase. Aquaculture has come by 5 times. Food production for human food is about 100%. we talk about aquaculture deals with the number of species. I'm sure Dr. Jaina mentioned maybe about the number of species potential of Indian aquaculture. Did he or not?
Yes, he told.
Yes. And we talk about, when we talk about aquaculture, we talk about herbivores, carnivores, omnivores, etc. This is something which is totally inappropriate. These are etymological issues. Herbivore means eater of plants or herbs. Carnivore is eater of meat. How many fish they eat meat? Except maybe piranha? Not many. So better we have to reason in terms of trophic levels. When we talk about trophic level, the human food chain, or on land, for instance, the human food comes from low trophic levels, mainly from here. We have corn, plants, we eat them. Then you have those who are eating non-vegetarian, it's sheep, cow, cattle, or whatever it is, eggs. They are all at the trophic level of 2. When we look at the aquatic food chain, everything is at the high trophic level, except maybe for some of these bivalves. All of them are above the trophic levels of 3. So there is a confusion between what we talk about herbivore, carnivore, omnivore. Almost even common carp is at this level. So we have to reason in terms of trophic levels. This gives basic information with regard to how we deal with in terms of growing them properly. For instance, here is an example, consumers and producers. And the terrestrial ecosystem, you have carbon producers about very high levels of producers, consumers are low. Whereas in the marine ecosystem, consumers are much higher than producers. Indian aquaculture. I'm sure most of you know. They talk about we are so big and so on. You have the number 1 is Katla, Indian major carp, Rohu. So less than 2 species make up for more than 50% of production. Indian production is about 9 million tons total. Just these 2 species make up for more than 50%. Almost all of them from low trophic levels. Less than 6 species make up for 90% of the production. That means you have this rohu, other fish pot, catfish, silver, and mrigal, and so on. And they have now, since a few years, this shrimp, vanamai, is coming up. I'm putting here, for instance, here, even right, there's about 1,000 tons in India. So we have very few species make up for the majority of production. But as an aquaculture, you have to feed them for knowledge on nutrient requirement, which is necessary for developing the fields. If you take the global level, even at the global level, there are 10 species make up for more than 50%. Grass carp to milkfish, all of them from the low trophic levels. Atlantic salmon is one, which has about 3.5 million tons coming from major 2 or 3 areas, Norway, Chile, and North America, Scotland. Meeting, international meetings or World Aquaculture Meeting, Chinese aquaculture, they talk about 200 different species which are grown. Every day a new species. Just to make the feeds, there are 40 odd nutrients which are, and number of species. Just imagine, it's impossible. Whereas when we talk about land animals, there are few species, but of course the same number of nutrients which are involved. So the challenge is very high. Aquaculture. Here on the right side, this is a curve for growth curve for in about 16, 18 months maximum. And here is Atlantic salmon. You have how many weeks? Practically 3 years. Aquatic organisms have different reproductive strategies. Income breeder or capital breeders. That means they have to be continuously fed or they have to store enough before breeding. Multiple breeding or only once. Fecundity from a few hundreds to millions of eggs per kilogram of female per season. Egg size can vary from 0.5 millimeter to more than 5 millimeter or sometimes more. Hence, larval size can change. Potential for intervention is high. They're pleiadic eggs. They have diverse defense mechanisms, innate, acquired, high susceptibility to environmental factors. Common features in aquatic mode of life, because we say so many different species, there are 3 points which are common to most, be it fish or shrimp or oikilothermy, that means temperature control. Ammoniotalism, that means nitrogen metabolism. Ammonia is released directly into the environment. They don't have to convert them into urea or uric acid. And simply because of the aquatic mode of life, the energies are lower than land animals. Here is an example. For instance, this is a Siberian sturgeon. We grow in France, for instance, a huge animal. So you could have zebrafish on the one side and such animals big size. So nutrition and feeding. It deals with understanding and assessing what happens after the food is eaten. It's the animal's requirements for nutrients and energy, that is part of nutrition, to meet the demands for physiological well-being, growth, health, reproduction, whatever it is. Nutrition deals with what happens after a food is eaten, digestion, absorption, excretion, retention, at different levels of organism growth, levels and genomic levels and so on. Feeding nature means search for food. The majority of organisms in nature, they're spending their lifetime food, obtaining and ingesting. Under farming, they don't have to spend energy for looking for food. We provide appropriate feeds in appropriate amounts at appropriate times to meet the different production targets that we fix ourselves. Here you have a pond somewhere in Andhra Pradesh. This is Dauli, this is a shrimp farm, and this is a Norwegian salmon farm, for instance. When it comes to the nutrition and feeding, there have been information. The first ever meeting on feeding the nutrient requirements was held in ago in Germany. There have been a number of books. There is a common book, it's called The Nutrient Requirements of Fish, NRC. In the 80s, we separated warm water fish from cold water separately, published in the 70s. 1993, it was modified that there is no such difference. Aquatic environment is together, warm and cold water fisheries together. I'm insisting on this because we have a confusion everywhere. Oh, cold water fish is different from warm water fish. Then, in 2011, there is a latest book on nutrient requirements of fish. We put fish and shrimp together in this. And there have been a number of books. And myself have put in French, Spanish, and English, the nutrition feeding of fish and crustaceans. And the latest, which I had the pleasure of uh, developing with Ron Hardy from the US, is the Fish Nutrition 4th edition. It will be a very good textbook for teachers if you are interested. But feed. In any animal production system, feed cost is more than 50% of the cost breakdown of fish or shrimp production. If you take poultry, it is just feeds and seeds, or seeds, beans, the eggs, production of juveniles, and so on. Secondly, the feed composition is totally different from land animals. Aquatic feeds have protein levels going from somewhere between 40 to 50%. Average aquatic feeds, you see, it can have from 50 to 30%, depending on the size, depending on the age, depending on the species. Similarly, phosphorus levels are very high. So these 2 points, nitrogen and phosphorus, are important in terms of maintaining the quality of the feeds, but also has implications in terms of environmental impacts. So what are the criteria for aquatic feeds? As I said, animals, all of us, need nutrients and energy, not ingredients. We don't need this specific ingredient or that specific ingredient, but what the people, those who produce the feed, they have to be serious about it. Cost, least cost formulations, and then market availability of ingredients. There are technological issues. Compared to land animals, aquatic organisms, aquatic feeds have to be very careful. We need particle size simply because fish and shrimp, they don't have teeth. They have to be stable. They have to be functionalities in terms of floating, sinking, or a number of other factors. When it comes to nutrients, we talk about proteins. It is amino acids which are required. We have marine origin proteins, fish meals, squid meal, krill meal, hydrolysates, and so on, plant meals and concentrates, single cell ingredients, animal processed byproducts, lipids. When we talk about lipids, we have to think in terms of fatty acids, marine origin, plant origin, land animal origin, and so on, carbohydrates, vitamins, minerals, additives to add other functionalities. Remind this is, for instance, let's say this is about 300 micron, this is about 5 to 6 millimeters, or 9, sometimes even 20 millimeter diameter. Each single particle should contain all this. So this is a big challenge. So the terminology that we have to remember at the FEFAC, it is called feed ingredients contain feed materials and feed additives. Feed materials, the principal purpose is to meet animals' requirements, nutritional requirements. Okay? It can be in different form. I'm not talking about, so feed materials are those which supply animals' nutritional needs. Secondly, there are feed additives, substances which are added, microorganisms or preparations other than feed material and premixtures, which are intentionally added to feed or improve. And this is a common thing which is called a dose response curve. You have the dose, different levels of a vitamin, for instance, an amino acid, for instance, and you have a response which can be growth, which can be something else, which can be an enzyme activity, which can be a particular nitrogen production, nitrogen gain, or whatever it is. So there is, as and when you increase the dose, there is a response which is never a straight line. It's always a curvilinear. And when we talk about efficiency, the maximum efficiency is somewhere here, beyond which the efficiency comes down. This is what is called the law of diminishing returns. And below a given level, the response can be negative. This is what is called the maintenance requirement, or at zero intake, zero gain of, for instance, growth, but still they are eating something. This is the maintenance requirement. All of us need. Majority of us are now working on maintenance requirement because we don't grow anymore. Whereas in aquaculture, they continue to grow, so they have to maintain anyway, whether you want to grow or not. At the cellular level, so such responses are common at the cellular level. Anybody who knows the enzyme kinetics, they follow the same at the organism level, at the form level, and so on. When we run trials like this, we need to have a control, replicable feeds. That means if somebody is doing a study in some part of the world, it should be replicable in other parts of the world. That means that diets, ingredient should be clearly defined, and there should be sufficient levels of doses, replications, duration of study, different size and life stages. And the response criterion here should be stringent, the most stringent response criterion on which you should base your requirement data. And there are a number of models and methods for data analysis. For instance, we talk about some species, panga. Even in India, now we are talking about panga catfish. In Southeast Asia, the production is about close to 3 million tons. But if you look at the published data on nutrient requirement, there's not much. So people are making money, the feed companies and the farmers, but without, it can be significantly improved if only we did rely on solid data. How do you do? There, I said about models. If you cannot do, you have to take factorial models, or one which are novel tools which are being developed for land animals and for aquaculture also. Maintenance and efficiency of deposition are gained. The nutrient requirements of an animal is an addition of the nutrient deposition in the body, maintenance, and losses, inevitable catabolism and fecal losses of the nutrient. This can be done if we have performance records, bioenergetic models, and so on. So this is something which has to be developed more and more. And as teachers, you will have to teach the students how to undertake such studies. There are databases available. This is one which is developed by Dr. Dominic Bureau, and it's at the IAFPD. You have such databases are available. When we talk about protein sources, in Indian feed, aquaculture, we do cereals and pulses, oil seeds. These are the majority of ingredients. Fish meals, plant protein concentrates, isolates, and now single cell proteins are coming up, which have high levels of protein. Cereals, pulses, oil seed meals have less than 25%. Oil seed meals, soybean meal or rapeseed meal or whatever it is, 25 to 45%. Then you have other novel. One point that we have to recognize is the same proteogenic amino acids, 20 amino acids, exist in all plant and animal protein sources, but in different proportions. The composition of one protein is different from another one. That makes the difference between one protein to another. But the gross energy from macromolecules like proteins, fats, and starch is the same whether it's of animal or plant origin. I'm talking about the gross energy. 1 gram of protein is 5.65 kilocalories, fat is about 9 kilocalories, starch is about 4 kilocalories, and whether it is of animal or plant origin. But if it is digestible energy, that will be a different from each of them and different depending on the plant origin. So we have to talk in terms of amino acid balance and nutritional factors. Global protein production. We all eat proteins, all of us. The global protein production for animal feeds, for instance, lupins, peas, sunflower, rapeseed, wheat, corn, soybean. The biggest two plant protein sources are corn and wheat. And they provide about 100 million tons each, compared to what fish meal provides, relatively very small. There are nowadays the processed animal proteins and others are coming up, but we have to also reason in terms of amino acids. This can be converted into amino acid code also. Secondly, the macronutrient oil production, which is the biggest oil production, palm oil, 75 million tons, soybean oil, and so on. And fish oil is less than 1 million tons. And this again can be converted into fatty acids. If you put all this together, there is very little omega-3 long-chain polyunsaturated fatty acids, little 18,3 omega-3, little EPA or DHA. So there is a big challenge is in terms of fatty acid supply. Aquatic organisms require. I'll come to it later. Amino acid requirements. This is what you call a Venn diagram of different amino acids. There are 10 essential amino acids. Quantitative data available for, this is a very recent work which I'm undertaking right now. It's not yet published, about different species around the world, the latest publication available. Look at the variation in the requirement. Somewhere from 2 to 6% of protein for different amino acids. Available data show much variability. But when we know, most important point is the whole body amino acid profile is a very good starting point for determination of requirements. When you have to work on catfish, for instance, the ideal way to start is to understand what is the whole body amino acid profile of that particular species. That is a very good indicator. This is what you should supply in the feeds. Then you have to know what is the difference between maintenance requirement and growth. And amino acids are involved in a number of functions. That's where confusion occurs. People talk about functional amino acid. All amino acids have functions. And there must be a dietary amino acid imbalance or antagonism. That means it could be due to excess or deficiency. The imbalance means it could be deficiency or excess. And amino acid in the body is in a dynamic process. There is protein synthesis and degradation, turnover. There is a dietary supply as well as endogenous amino acid supply. So this is a dynamic process. See, I'm giving this example. This was done about 70 years ago. Amino acid balance and imbalance, Harper's. We still do not follow that. We have to follow all the amino acid balance, not to reason in just terms of proteins. Fatty acids. We talk about so much about fatty acids. If you look at available data on the requirements, very few studies have ever taken graded levels of supply and a response. This is an example with rainbow trout and Atlantic salmon. This was done about 30 years ago by Japanese scientists. Unfortunately, For majority of the species, that such studies have not been undertaken. So this is another good challenge. Available data on essential fatty acid for different species, warm versus cold, marine versus freshwater, whether it should be DHA or EPA or omega-3 or omega-6. Is there a reason to work in terms of ratios? There is no clear evidence of a DHA-EPA ratio. Is there a dietary need for cholesterol in shrimp? What is the phospholipid? And so on. For instance, this is, I mentioned about Atlantic salmon and rainbow trout. Very recently, some studies have been undertaken with marine fish, a fast-growing marine fish. And see, depending on the model that you use, depending on the levels of incorporation of dietary fatty acids, you could end up with requirements which are totally different. You have 3% DHA which is required, and here it's about 2.1%. So there are confusion between data which are available. Carbohydrates. Of course, there is a big source. We always say fish cannot replace carbohydrate. Look at the glycemia. That means plasma glucose levels. Fish ranges like this. Amphibians, reptiles, birds, and mammals. Not big difference. This is one of the early studies by Japanese scientists to show that people used to think our fish don't have insulin. They clearly showed there are insulin secretion. There is no problem. It is a question of receptivity of tissue, glucose phosphorylation, tissue receptivity are different. And some of the major scientists like Erika Plisetskaya and Tom Moon have said some of my not so favorite things about insulin and insulin-like growth factors in fish. It's better to read such basic data. Glucose intolerance in Tilia's fish, fact or fiction. They're very nice studies clearly showing that we are talking sometimes inappropriately that fish cannot. Nobody can utilize carbohydrates. Fish do utilize carbohydrates. There is no intolerance. You don't kill fish with starch supply or glucose supply. So the concept of glucose intolerance is not clearly established. It's a complex chemistry, provision of net energy, and so on. And at the feed level, high levels of carbohydrates can lead to problems in terms of Maillard reaction. Sometimes even formation of acrylamide in the diet if the extrusion technology is improperly used. Vitamin nutrition. Dietary needs for most water-soluble vitamins do not differ even between phylogenetically 4 different species. Fish and chicken, and there was even a study by Bill Woodward, 1994. He very clearly showed, he compared salmonid, chick, and pigs, and so on, monogastric, to show that there are not much differences. There is an overriding similarity among different species of fish, birds, and mammals with regard to dietary requirements for them. Why I'm saying is, before that, John Halver, who was the founder of fish nutrition study, data were inappropriately showing that vitamin requirement may be too high. In India, many people are still using those diets with putting high levels of vitamins, and this is just going into the water. But what is important is you have to think the form of supply of vitamins. Some vitamins supplying, for instance, ascorbic acid into the water is totally useless. You have to use protected forms, sulfate or phosphate forms, must be monophosphate or polyphosphate forms of vitamin C, for instance. There can be excess supply of hypervitaminosis because of, for instance, vitamin A excess can lead to deformities. There are interactions between vitamins, it's called vicariance. Physiological functions. You have reproduction, there are fat-soluble vitamins that are important, vitamin E, D, K. Minerals. When we talk about minerals and trace elements, there are differences between feedstuffs, ingredients. Fish meals, for instance, have levels, and sometimes plant protein sources are considered to have low levels. But sometimes, for instance, magnesium, you can have high levels. Sometimes manganese, you can have very high levels even in the plant protein sources. So there are differences between sources, and we also have to clearly determine the availability from different sources. When we are talking about aquaculture, we are talking with aquatic environment. It is also a potential source of minerals and trace elements. Here is an example of salmonids, which can go into freshwater or seawater, euryhaline animals. Fish in freshwater do not drink. There is a branchial uptake of water and electrolytes, urinary volume high, dilute in ions. When the same animal or any marine fish in seawater, they drink a lot. We call them a sponge. They actively excrete electrolytes through the gills. Urinary volume is low, but very highly concentrated in ions. So when we're talking about recirculated aquaculture system, for instance, we have to take into account such concepts, whether how much of water is bearing whatever is not utilized by the organism, it's going to be in the water, and this can influence the animal's uptake, potential uptake of minerals or trace elements. Some of the studies undertaken by ourselves, for instance, with Anthony Jesu Prabhu, we started working on it, and he is now working in Norway. Saravanan, for instance, a study, he's working in Norway in a feed company. They have all looked into such of this mineral requirements of fish. This is just to show examples of reviews which I made with Santosh Lal. These are extremely useful information. Technology. When we talk about larvae, body weight can be less than 1 milligram. Diet particle size is less than 100 microns. This 100 micron should contain all the nutrients in an available form. Sometimes you have big fish, 5 kilograms fish. Diet particle size can be 2 centimeters in diameter or more. Okay? So you have to be thinking this is not very common in land animals, such big difference. Extrusion technology is becoming more and more common. But still, in India, you have still foam-made feeds using a simple seva machine. Issues with aquaculture feeds is water stability, palatability, texture, friability, fines, etc. Floatability, density, and improving the starch digestibility. Reduction of anti-nutrients. Any extrusion cooking removes anti-nutrients or reduces the anti-nutritional factors. It can allow for increased fat coating. Feeds for recirculated aquaculture systems. So as a nutritionist, I used to say we used to work on high nutrient dense diets. Now we have to work also to make stable food. Producing fish with fish. This is something which is FAO and everybody, because capture fishery derived feedstuffs are sometimes used as feedstuffs for fish. And people realize still that we have to have fish meal and fish oil in the feeds, which is not necessary at all. Over the years, the levels in the fish meal has been coming down. This is an industrial level. It's happening. Salmon feeds have come down to very low levels. Trout feeds have come down. Bass and bream, these are marine species. Same happens with fish oil. And this is all done because we have been working over the past 20 years, and I've been involved more or less with all these European projects, international projects within different countries, different groups of scientists, different ideas, talking about feed to human health. fish meal replacement, fish oil replacement, what happens at the gut, what happens to the PFA levels. So fish meal replacement by a mixture of plant protein ingredients has been done. This is different examples: trout, sea bass, sea bream, as well as Peneus monodon. This was done by my students. So all this can be done, showing that if you are formulating the feeds based on amino acid availability, looking at the number of other factors, it's totally possible to have totally fish meal free diets. This is an example of what is really happening in Norwegian salmon. 1990, the marine group, marine products, marine proteins and oils were about 90%. That was about 30 years ago. Now, see, 20%. Marine oils and marine protein sources, and the same thing applies to trout. So, these are commercial 3 million tons of feeds which are being used, and totally less and less of fish meal and fish oil. If they can do it, which can be done to all other species. I'll come to Indian aquafeed sector. My numbers may be wrong, maybe they are changing. There are about 1.8 million tons of shrimp feed and about 1 million tons of fish feed in India. My numbers, maybe you people know more than I do. 40 dedicated feed mills concentrated in Andhra Pradesh, but spreading everywhere. Technologies is pelleting, extrusion, floating, sinking. Production capacity is increasing. Every day they say that I have big and big factories are coming. More and more actors, including international, almost all major aquafeed companies getting involved. Almost all major aquafeed companies, international companies, are also settled in India. Just to show an example of that's feeds, now feeding. I don't know whether you have seen such systems. It's in Andhra Pradesh in one of the carp ponds. This is called a bamboo sticks with the feed bags. They go and fill it up and say the fish and so what you call indigenous self-feeders. And this is a highly sophisticated system which is used in Norway, for instance. It's almost like a castle in the middle of the sea where you have the feed barges there and the tubes supplying feeds, and everything is controlled by computer. Floating feeds can be a very useful management tool. Fish don't need, it is for us to see whether fish are eating or not. But we still require close control of uneaten feed. This leads to some of the questions like precision aquaculture. You will be coming across these questions. When we talk about precision, and here they are very precise, but totally wrong. Here, no precision, large bias, generally wrong. Here is what is precise and right. This is the correct. And this is no bias, but low precision, generally right. So, for instance, when we talk about precision and accuracy, we have to be careful that we have to be here and not here, and not at all here. So, when we talk about precision, we have to think in terms of what does it mean. Currently, such precision livestock farming, precision farming, is more devoted towards husbandry management than on feeding and nutrition. A number of computers and electronics in aquaculture now. Computer vision, fish detection, behavior, species. Every other day there is a program in India also on precision. We have to develop automatic feeders. But how much to feed, they don't know. We develop automatic feeders, but we don't know how much to feed. So, sensors, there are a number of sensors available, physical, chemical parameters, measuring pH, water, salinity, temperature, oxygen, and so on. And one thing which is working more or less is supply of oxygen. Depending on the water quality, you can supply oxygen. But when it comes to the feed, we have to follow some of the basic principles of bioenergetics to supply how much to feed. So these are some of the feeding systems: hydrophone feeding control system, sensor-based feeding control for pond aquaculture. Some of them are already operating in India. I think this is one which is in India. Environmental impacts, fish to farm level. Aquaculture, compared to land animal production, is dependent on the quality of its water. So we have to maintain good quality of water. Otherwise, we cannot have aquaculture. Knowledge gained on nutrient flow dynamics. Nitrogen, phosphorus, I mentioned. That means whatever we are putting, it should be available to the fish, not too much, and it should be retained by the organism. So when we are working on individual fish, can be applied at the farm level using appropriate tools and models. It has been verified at farm level. Full extension needed across the sector, across the state, across the district, so on. Beyond the farm level, there are a number of other sustainability issues these days: carbon footprint, environmental footprint, water footprint, environmental performance. These are questions which are coming up every day. But what I suggest is that resource utilization efficiency, that means increasing the efficiency of feed and nutrients, is the most important. Nowadays, it's also a question every day, other day you have certifications: organic, clean, honest, and so on. Ecosystem approach, that means you have to think not only just at the farm level, but going beyond. But as in all animal production systems, we have multi-users, right from the farmers to at least until the consumers. It's a common, they have a synergy as well as compromise. A new concept which is coming up is, can we program the physiology and metabolism of fish? For instance, we can modify the composition of the eggs. You put them in specific water-soluble mixtures. They can uptake some amino acids. They can uptake some water-soluble vitamins. You can inject individual eggs. You can do sonophoresis, ultrasound injection, and you can also modify through broodstock nutrition. We have done with number of students. There are people, and there are now programs even in India: fatty acids, low fish meal fish oil, sulfur amino acids, vegetable ingredients, vitamins, and so on. This is at the broodstock level. Then once the eggs are laid, you can change the first feeding of larvae and alevins. You can number of, and this can have acquisition of new phenotypes. That means you can imprint the animals so that when they are confronted with challenges later in life, they are capable of accepting such changes. So this is a physiology and metabolism. This is very much promising area. There are a number of such studies. I'm not going to deal with this now. Secondly, we use almost all laboratories in the world, in India also, we use what we call gene expression tools. That means mRNA levels, gene expression, nutrigenomics. These terms are used sometimes not properly, but what I say is integrative omics tools, proteomics, genomics, and so on are being increasingly used. But we have to be careful. We need dedicated studies to separate the effects of specific nutrients, whether it is a sulfur amino acid, or it's a lysine, it's a tryptophan, or it's the vitamin C or vitamin B12, which is having an effect. We cannot just do diet 1 against diet 2. Responses at the molecular level have to be always complemented with responses at the biochemical or at the whole body level. At the molecular level, we cannot quantify the responses, though there are tools nowadays, but from one study to another, you do not use the same reference. So it's difficult to comparison between species and studies. Suggestions. I'm coming almost to the end. Standardized nutrition trial protocols, ingredients, biological values and requirements. We need integrative approach. We have to generate basic knowledge using all possible levels, whole animal level. If an animal is not growing, then there is no point in working on the molecular level or cellular level, unless we are specifically working on what is the effect of starvation. It should be interdisciplinary and comparative. Comparative not only between species, but also from land animals and so on. Digital tools based on solid science. These are coming up, and India has a very good potential in terms of information technology, factorial models, needs, and feeding. And as teachers, you have to be involved in e-learning, massive open online courses. This is going to come anyway. We have had 3 years of the COVID. People have been starting even lectures like mine now from very far away. With such a distance, we are capable of communicating. So we should be able to do massive open online courses. Cooperations, networks, national, regional, and international is something which is important. Finally, I will stop here. This is something which I see here. For instance, this is somewhere in Agra, and this is also in India. Somebody is promoting Atlantic salmon in a big restaurant. What I say is, if you go to a big restaurant, often we see salmon, we don't see Indian fish. So this is where I want to say that increase awareness on the benefits and nutritional value. We need open databases on seafood composition, something which has started with FAO, has started with the global food composition. We have to involve local communities, increase local consumption. This is a very old picture. I said Indian aquaculture, how many people eat in different areas of India is different. This is our friend from Gujarat who has had the jingalala for shrimp for domestic consumption. These are katla, and these are some of the novel initiatives that increase the local food consumption. I stop here. Thank you very much.
Thank you, sir, for this very informative. What I should say, I cannot say that how your lecture is. It is really excellent, and we are learning so many things, and it is also helping us to select some new area for the research. We are really thankful. And now it is open for the question. Whatever you want to. Yes.
Good afternoon, sir.
First, you introduce yourself.
Sir,
I'm
Dr.
Back to आपने introduce करो.
Sir, I am Dr. Tarun Kumar from Shahid Rajguru College, Department of Biochemistry, University of Delhi. So my question is related to some metabolic disorder. For example, if we talk about phenylketonuria or homocystinuria, for example, in case of phenylketonuria, the patient is suggested to have diet which is restricted with phenylalanine. So can we design or can we produce fishes in such a way that they will be having proteins and that is having less content of phenylalanine?
No. Okay. Yes. Okay. A protein, we talk about proteins. Okay. What are the proteins in fish?
He doesn't know. Actually, he is not from fisheries.
No, I'm kidding. Let's talk about ourselves. We have what? Myosin, actin, collagen. You understand?
Collagen, actin, and cytochrome.
Yeah. There are the different. So there are different proteins that are there, and they have a composition which cannot be modified. Otherwise, it will be called another protein. You understand? An actin is always an actin. Myosin is a myosin. Of course, you can have different varieties. So,
it will be very difficult to.
Yeah. So we cannot modify the composition, we can do. What we can do is possibly, otherwise, a chicken will not have the same composition if it is grown with seeds or with something else. It will have the same protein composition. We eat different proteins, all of us, but all of our proteins are very similar. Okay. What can be modified is only the free amino acid portion. You understand? So when we are talking about the phenylketonuria and so on, it is only the free amino acid portion which can be modified by dietary factors. In no animal, we can modify the protein content itself, protein composition. Otherwise, this is going to be a big case like what happened with the prion disease, you remember? Yeah. So that's a big danger. We cannot change the protein composition. We can change only the free amino acid composition. And free amino acid portion is a very small portion of the whole body.
I agree, sir, because that will be having impact on the protein conformation as well.
Yeah.
And the
It's
function.
okay? My answer is okay for you?
Yes, sir. Absolutely.
Next, anyone? Rohini, you want to ask anything? You are physiology student? यहाँ पे आ जाओ, थोड़ा आगे आ जाओ बेटा, आपने इंट्रोड्यूस करो.
Good afternoon, sir. I'm Rohini
Good
Arya from
afternoon.
College, Department of Zoology. My question is, sir, like if we go for fish, apart from fish feed, if we go in animal, we have many commercially available feeds, and sometimes we say that the costing of that feed is very high. So, what about fish? Like, how much are we indigenous, and how much are we importing it from outside? This is a new thing which I'm seeing, that the trend is that we are importing a lot of animal food from outside, and it's being really advertised in a way that this is better than our own food, like apart from fish feed. So I would like your views on fish feed.
No. Okay, I did not get exactly the question. If I understand, you are saying that there are some who promoting feed coming from outside as being better than feed produced locally. Is it? Yes?
Yes,
Is that
sir,
the question?
yes, that's my question.
Yeah, okay. So, no, yes. This is always the case everywhere, because sometimes it was the case now. For instance, you have some of the big actors have been involved, and maybe yesterday you had a pleasure of talking with Professor Sorhalus. He was the man behind the Artemia.
Yes, sir.
Okay? So, there is a big company which has been promoting Artemia.
Right.
Not only Artemia, but also the enrichment mixtures.
Right, sir.
Okay. Number of Indian scientists have been trained. Huh?
Right.
Yeah, okay. So what is the thing is, not everything foreign is better. Okay. But there are application of such knowledge can be done. Now, for instance, Indian feed industry is strong enough. They are extremely efficient. Some of the companies I have visited, I have had the pleasure of seeing some of them. They have up-to-date technology and also up-to-date knowledge of information available to other everywhere. Okay. So this is something which is, there is a transition period. Now there are big companies coming. Of course, some of the big companies have some specific knowledge because of basic research there. Now, one of the things which I find, and we have been, for instance, when I mentioned about European projects, in all of it, we have industry participation. They learn from us, you understand? They learn from what basic science, and they are the application. As a scientist, we have generate knowledge for application by somebody else. We cannot do both.
Yes.
So our knowledge should be useful for application by industrial partners. And this is a mutual benefit. For instance, I give an example. I want to buy I'm from one of the Indian institutions. I have to make feed. My volume of feed, I'm going to make maybe 50 kilograms.
Right.
Where I'm going to take a cycle, go to the supermarket or whatever it is available, and sometimes I know fish meal. I go buy fish in the market, come and dry in my sun, grind them as making a fish meal.
Right.
Unfortunately, this is what is happening.
Yes.
This cannot be considered a good quality fish meal. This is already burnt because of the sun, oxidized. So whenever you use replacement of this fish meal, it will always work better because this is not a good quality fish meal.
Right.
Okay. Yeah. Over the past 20 years, slowly Indian fish meal companies have started using good technologies, followed by what is being done elsewhere. So the quality of the fish meals are better. What I'm saying is our knowledge of economics, because we are not going to calculate how much of what is the cost. Majority of scientists and senior scientists generally, what is the cost? Is exact. I'm going to a bank, and if he talks, that's a very useful one. Yes, I don't know whether I have answered your question.
Thank you, sir.
Yes, yes. Thank you. You can ask.
Yes, I'm me.
Yes.
Dr. Regina from Gargi College. So the concern which I have is like we have done so many lab studies, then we brought it in the field, the actual environment, the actual system. But there has been so many questions earlier also for genetically modified food, which we know after 15, 20 years what could be the side effects. Likewise, whatever we are doing scientifically will surely or might have negative impacts later on. So, how do you feel? Do you feel that much gap has been breached? Or what do you feel could be the side effects of what we are doing regarding the fishes or the change in the food composition, etc.?
No, okay. You cannot modify. See, we have a confusion here. Animal composition cannot be modified. Protein, fat composition, yes. Fatty acid composition, yes. As I was mentioning to the gentleman from the biochemistry department, protein composition cannot be modified. You can have the free amino acid composition. You can have the contaminants coming into the issue. Fatty acid composition can be modified. Vitamin levels, water soluble vitamin levels and fat soluble vitamin levels can be modified to a certain extent. Trace elements. Okay. You cannot modify the protein composition. So fatty acids, yes, depending on what you eat, what the animals eat. They are reconstructed. Okay, so that's something which happens. So that is one thing which is what is a general idea when you look at as and when livestock production is increasing. One of the things which is common is the fat deposition is increasing growth rate, increasing fat deposition. So this is something which is very common. Land animals, the life cycle is short. Let's take broiler chicken or eggs and all that things within a span of 2 or 3 months you have. Okay, whereas in fish it takes long, and it's not only the feed. And if we are talking about the pond culture, for instance, it's also the water quality, the natural supply of nutrients has an impact. Let's take Kolkata, East Kolkata, the water bodies. What is the water quality there? It's a big producer and big fish eaters there have a definite impact, environmental borne, food borne, but some of the things which are not modifiable is a protein composition, for instance, cannot be modified.
I was
What do you want?
I was in Nife.
What do you want?
I was in Nifes as well as in University of Bergen with Christine Ivar. So you have given many new informations about making and selection of the different sources. But I have to know about like how we can add probiotics, whether we should or that should be in the water. So I want to know about that.
Okay, now.
What will it be and also having the growth?
No, see, India has, one of the things which you have seen is India is an excellent market for probiotics. All the companies are happy. Because see, they have very little solid knowledge on probiotics. You have to undertake serious studies, okay? Whereas a yogurt is a probiotic, okay? And so you have a number of such probiotics which are being commercially available and so on. So there serious studies have to be undertaken, which is definitely not as complete as it is can be done in a very simple way. Probiotics, why is it not used in salmon culture, for instance? You understand? Ourselves, we have, myself with my colleague Dr. Gatsu, have developed. And one of those, which is European accepted one, is, we found it had some beneficial effects on skeletal development in rainbow trout, salmonids. So that is applicable. So it has been tested a number of times and so on. Similarly, the same, which was tested in shrimp under controlled conditions. You do it under controlled conditions is one thing. And then you apply into the pond, that's a different story. How do they, you understand? So we do not have, unfortunately, pond replication studies.
Maybe because of the water temperatures in European.
Not only, it's not only the question of temperature, it is a question of the water chemistry as such. The whole, one of the things which was done a number of years back by the FAO is the creation of SIFA, NACA. You can do studies. I have done myself as part of the European project with NIFES, in fact. We have done studies in Bhubaneswar. But one pond from another, you need to have at least 6 ponds to have replication which are okay. Because depending on where the sunlight is coming, where the water is drawn and so on, it's different from what you see in controlled conditions in tanks. Even then, just 3 replications is not enough. Unfortunately, we do with 3 because there's not enough tanks and so on. So one of the biggest issues is again the replication. Whereas when we are talking about land animals, we can have as many replications because we are growing them individually. There is a big difference between land animal work and in aquaculture work. So we have to be extremely solid when we want to do with the probiotics. We have to do it under controlled conditions where everything is kept under control. Then you can demonstrate what are the beneficial effects and so on. Otherwise, then it's the same story like green water technology, bioflocks. You understand the science behind is very complicated. It's what you call black box, unfortunately. Yes.
Thank you, sir. And I think, sir.
Okay. Your turn. You can ask.
Sir, there is
Yes.
one more. Okay, sir. Sir, in hot climate conditions, not growth of fishes. So the fish grow optimally in hot climate conditions.
Depending
so can
on
we
the
use
species, yes.
can we use biotechnology application and can we modulate the level of molecular chaperones so they become resistant to extreme temperature?
Okay. Oh, this is something which we have been thinking about long back. Okay, there are two extreme situations now with the climate change and things like that. Very, very serious issue. Okay. One of the things which is clearly possible is, like I said, programming during early stage. Okay, imagine you have just hatched fertilized eggs. Okay, give them challenge. Okay? Grow them at a different temperatures. Very short challenges, few hours. This is where the window of intervention has to be imagined. So you have fertilized eggs, which are challenged to different temperatures for a few minutes, few hours. Then put them back into normal and see if they can tolerate 6 months later high temperature. So this is the concept of programming, it's environmental programming, which is definitely there are a number of attempts already being done. And so this is something which can be done to address such issues. For instance, this is an issue, or you are talking about 28 to 32, when we are talking about majority of fish which are grown are much less temperature, lower temperatures. So when the global warming is happening, what is happening is what's going to happen to Atlantic salmon, which is the highest temperature tolerance, is 15 or 16. Whereas in India, rainbow trout is grown at 18 in Bhimtal.
Yes.
So you understand this. This is a very good area where you can undertake studies with first feeding or immediately after fertilization. We don't know exactly the window where you can afford to give them thermal challenge. It could be oxygen challenge, it could be pH, whatever you like. I mean, you understand the idea. And then you can put them 6 months later, but challenge them to the same thing. It could be simple HSP, heat shock proteins, for instance, as a response criterion. For instance, you can have a number of other things.
So that means at the gene level we can further do the work. That is the
This is what is called. But this is what is called now called nutritional programming, or what is the phenomenon? We don't know. Okay, how is it operating? Okay. This is very much tested now with a number of species. Yes, definitely.
Any more questions? If come here.
Hello, sir. I am Dr. Dhananjay from Maitre College, University of Delhi. My question is, in your one of the slide, it was written as first feeding larvae or elevens. You are suggesting that high carbohydrates and low omega-3 and L-C-GUFA should be given. But generally,
No. I said studies have already been undertaken to challenge, exactly like what the question I was mentioning, to see, because we say that fish are not capable of using carbohydrates efficiently. Okay, so give them a challenge very early stage. High carbohydrate diet, high glucose diet, low fatty acid diet. Okay, so these have been published already.
But
so you understand yes, to see whether 6 months later they are tolerant to high carbohydrates or low fatty acid, which happens.
Okay. So it is
yes.
by the study.
Sorry?
You can see those publications. Then you will get all these things. It is already published paper, so he can go through the publication. I'm just giving him suggestion.
No, let me go to, yeah, okay. If I can show this same, yes. Let me,
It's a chair, sit here.
yes. You see this? This is the one you're talking about.
You have to present yours, share your slide. Yes, now it is.
Yes? Okay. So when I say this, let me see, yes, here, okay. First feeding larvae, high carbohydrates, low omega-3, no fish meal, fish oil, all plant diets, high sulfur amino acid or low sulfur amino acids, selenium. These have been already tested with one of these species. For instance, here, there is a PhD thesis which was done 2 years back, parental selenium and antioxidant status in fish. That means they gave the fish broodstock as well as the egg with selenium low levels or high levels. Sarhad Turkman and Feroz Khan, now he is in Bhubaneswar. Nutritional programming through broodstock diets with low or high omega-3 diets. Is that clear now?
Yes, sir.
So I think any more questions? Thank you, sir. I think all of them have enjoyed and learned many things from you, like us.
No, it's a pleasure for me. Yeah. Mm-hmm.
Okay, sir. Thank
Nope,
you.
it's not. I don't know. I didn't have a control of time. I think maybe I took too much time.
Oh, no. It is really enjoyable, and we learned so many things. And when are you coming to India?
Hey, definitely. No. It will be a pleasure to be there. Okay. Now, last time I was there, almost a year back, I was in Delhi. Yeah. Mm-hmm. Yeah. Yes.
Almost this time you visited India, June, July. I think you last year.
Yeah, end of July. Yeah, it was first. Mm-hmm. Yes. No. Right now, no. Yeah, it will be a pleasure to be. Anyway, Doctor. Thanks for all of you for your patience and good going. I think your week is over.
Oh, it will be over on Sunday itself. Up to 5 days they have to come here, and then 2 days they have to work from home. So till Sunday they have some activities for this course.
All the best to you. All the best. Very good. Thank you.
Thanks a lot, sir.
Thank you. Bye-bye. Catch up. No. Okay, you can always send. I will send you my corrected latest version of PowerPoint as a PDF. Okay.
Thank you, sir.
Okay. Okay. Bye-bye. All the best to you. Now it's tea time for you.
Yes.
Yes, sir.
Tea is coming.
Tea and samosa. Tea with samosa.
Good. All the best.
You will not get samosa in France. But home you will prepare, I know.
Yeah.
Madam.
Bye-bye. Bye then.
आप काट दीजिए हम काटेंगे
You can break. Yeah, please.
I will not close. आप क्लोज कर दीजिए.
Yeah.
हम नहीं करते.
मैं बंद कर देता हूँ हमारा भी